Hey there, Math Hoppers. In this video lesson, we are going to learn how to graph quadratic functions as well as how to determine the solution to a quadratic function from the graph. So this will start out as a review. Remember that the quadratic functions are written in standard form as ax squared plus bx plus c equals 0. Remember the highest exponent of 2. A, b, and c are simply real numbers, and clearly a cannot be 0 because then we would not have a squared term and we would not have a quadratic. All right, so the graph of the function is a U-shaped graph. It is called a parabola. If a is greater than 0, this is math talk for if a is positive. If a is positive, the parabola opens up, and if a is less than 0, what kind of numbers are less than 0? Negative. So this is math talk for if a is negative, the parabola opens down. Here are some examples. I'm sure you have seen these before. So let's get into the most basic form of this. If we look at the graph of f of x equals x squared, this is called the parent function for quadratics. There are many parent functions. We have a video on parent functions if you want to go over them. But think of the parent function as the simplest form of that function. So f of x equals x squared is the simplest form of the quadratic function. Okay, so looking at the graph of f of x equals x squared, you'll notice the symmetry in the graph. Okay, so we have the points negative 3, 9, and 3, 9. We have the points negative 2, 4, and 2, 4. We have negative 1, 1, and 1, 1. We also have this point down here, which has got its own special name. It is called the vertex. The vertex on a parabola that opens up will be the minimum value. All right. The axis of symmetry is the vertical line. In this case, the line x equals 0, right? This is a vertical line going right over that y-axis, so the equation is x equals 0, that cuts the parabola in half. So, for all quadratic functions in the form ax squared plus bx plus c, if a is positive, we already talked about this, the graph opens up. And when a is positive, the vertex represents the minimum point, the lowest value on that function. The x-coordinate of the vertex is found by evaluating negative b over 2a, or negative b divided by 2a. So you would take the opposite of the b value, that's what negative b means, divided by 2 times the leading coefficient, or a. And we are going to see that shortly. Let's look at the graph of f of x equals negative x. So if we were to reflect this over the x-axis, okay? So if you look at it, it has many similarities. It really has just been reflected over the x-axis. It still has symmetry. For negative 1, there is 1, negative 1. For negative 2, 4, there is 2, negative 4. For negative 3, negative 9, there is 3, negative 9. Again, there is a vertex. The difference here is because this opens down, the vertex is the maximum value. There is still an axis of symmetry. Goes straight down the graph. In this case, it is still x equals 0. For all ax squared plus bx plus c, if a is negative, the graph opens down, as we see here. It is reflected over the x-axis. And when a is negative, that vertex represents the maximum value. The x-coordinate is found exactly the same way, no matter if it opens up or down. The x-coordinate of the vertex is found by taking the opposite of b and dividing by 2 times a. All right, I think we're ready to graph one. Let's graph x squared minus 6x plus 8. So the first thing we have to do is find the x-coordinate of the vertex. If you remember, we said the x-coordinate was x equals negative b divided by 2a. I find it very helpful to go ahead and write out your a, b, and c values immediately when graphing. So notice there's no number here in front of x squared. That is 1. The coefficient is 1. If there was another number here other than 1, we would have written it. It's clearly not 0 because then there wouldn't be an x squared term. So when you don't see a number here, the coefficient is 1. B is negative 6. Do not forget your negative sign. And C is 8. So let's write those out. I have A and B in red because those are actually used in the vertex formula. Now let's plug them in. X equals negative 6. Really, you'll never write it like this, but since we say negative b, that's what we're doing. We're negating the value of b. So if we negate negative 6, we get 6. Mostly just remember it's the opposite of 6, or the opposite of b. If negative b means take the opposite. If it's positive, make it negative. If it's negative, make it positive. So we get a positive 6 divided by 2 times 1, which simply is 6 divided by 2, which we know is 3. Okay, that's just the x coordinate. We need to plug that in to the equation to get the y coordinate. So we get the entire vertex. Remember, that's just half our vertex. Every point has an x and a y coordinate. So we're going to take this value of 3, and we're going to plug it in here. 3 squared minus 6 times 3 plus 8. And let's go ahead and see what that looks like. We get y equals negative 1, giving us a complete vertex. The vertex is the point 3, negative 1. Now we will make a table of values, and we're going to pick 1 point above the x-coordinate for the vertex and 1 point below. You want to see the graph on both sides of the vertex. It makes a U. You want to see the U. The only way to do that is to have both sides of the vertex represented. Okay, we're going to need a new screen though. So graphing still, y equals x squared minus 6x plus 8. We are going to make a table. Remember, we already know the vertex is 3, negative 1. That is our vertex. We found it on the previous screen. Now we're going to go ahead and plug in a value less than 3 for x. So let's say 0. Plugging 0 in, 0 squared minus 6 times 0 plus 8 is simply y equals 8. Let's pick another value larger than the x-coordinate of the vertex. So notice I went 3 lower. I went to 0 because 0 is easy to plug in. That's honestly why I picked 0. But since I went 3 down, I should go 3 up to show the symmetry in the graph. So let's plug in 6. It's not too terrible for this equation. 6 squared minus 6 times 6 plus 8, 36 minus 36 plus 8, and we get 8. Okay? Now, if I had gone 5, these outputs would not have matched, but because I went 3 below and 3 above, they do in fact match. All right, now we have some points. Let's get rid of this room and make some room for a graph. The last step is to plot those 3 points and to draw a U-shaped graph through those points. Remember, these are always U-shaped graphs. So let's get us a graph. Let's plot the 3 points, and let's see how good I can draw on this board. Sometimes it's not super friendly with me. And this, oh, that's not so great. It would really go kind of down through here. There we go, much better. We'll just pretend I meant to do that. And there is our parabola. Put some arrows there because it goes on forever and ever in the positive direction. And we have graphed y equals x squared minus 6x plus 8. All right, now, graphing quadratic functions. Here's your step-by-step guide. You're going to use negative b divided by 2a to determine the x-coordinate of the vertex. Remember, that's just half the vertex. So you're going to plug that in for each value of x in the equation. Normally, there'll be an x squared and an x term, so you'll plug it in twice to most equations to determine the y-coordinate of that vertex. Then you make a table of values with a point above and a point below the x-coordinate of the vertex. And you're going to plot all those points and draw a U-shaped curve through them. Now, the graphs of quadratics are actually helpful. If you are given the graph of a quadratic, you can determine the answers from that. Remember that the standard form of a quadratic function is ax squared plus bx plus c equals 0. So that equals 0 tells us something very specific. It tells us that we are solving for x-intercepts. Remember, this is where our f of x is or our y is. So when that is 0, we are dealing with x-intercepts. So the solutions to these graphs are the x-intercepts. So if we label them right there, the solutions of a quadratic function are the x-intercepts of that graph. This will only be true for real solutions or quadratics that have real solutions. Okay, so we can see here that the solutions are -3 and 2 because that is where our x-intercepts are. Okay, I said real solutions. So what about those quadratics that have imaginary answers? The quadratics that have I in the answers? Well, the graphs of those will be floating. They won't have x-intercepts. Imaginary solutions cannot be determined from a graph since the graph doesn't have any x-intercepts and the x-intercepts are the solutions. Make sense? Okay, so what is the solution or solutions for this quadratic function? Let me give you the graph. All right, remember, the solutions are the x-intercepts. So to determine the solutions, let's locate those. Put a plot there, -3, 0, -2, 0. There we go. Even though the solutions are the x-intercepts, you're going to love this, there are different terms that refer to this. Sometimes they won't ask for the solutions. They will ask for the x-intercepts. That's really nice when they do that. They don't usually, though. They normally say, determine the roots or the zeros. So here you have it. The words solutions, x-intercepts, roots, and zeros all mean the same thing for quadratic functions. If you see something that says determine the roots of this quadratic function, they are looking for the solutions or the x-intercepts. If you see something that says locate the zeros, and that makes sense. Remember, we're setting it equal to 0. We're looking for x-intercepts, which are zeros, which are solutions, which also are roots. Why they couldn't pick one name, it's beyond me. Maybe just to confuse everybody. All right, so if you are having trouble with anything that you see in class, your homework or a quiz in this module, you should be subscribed to our YouTube channel. And if you are struggling, go ahead and submit your problems to us, and we will make a custom video solution that will help you out. Until next time, Math Hoppers, take it easy.